Okay, so any questions about anything so far? All right, so new topic. So it feels like we're going kind of quick. It's because we are, so really we have like another week and a few days left of class. So we're just cruising along. So, like each class is like, whatever, two and a half lectures of a regular class. So our next topic is arrays, and arrays are really useful and pretty common for most programs. So to motivate them a little bit, if you've got something like the trivia game we're working on, or like in my notes I have an example like for inventory of items. So maybe you got a store of items. What we've done right now, if you wanted to keep track of like your inventory and prices, you need a variable for every single item. So maybe you have like an int for how many of your first item, and then you might have like maybe a double for the price of it first item. And you could repeat this for your second item. And so on. And if you only have a couple items in your store, then this is probably fine. But if you're like any store that has more than a handful of things, or if you have thousands of things, then programming wise, it would be really inconvenient to have this thing go all the way up to, you would have to type in, num item 1037 or something. So it seems like there should be a better way to essentially make a bunch of variables all at once. So a way that you can sort of programmatically say, give me 1037 integers just in one shot. And there's a way to do that. And to do that, it's called arrays. And what an array does is it gives you multiple variables of one data type. So it'll let me create, in this case, 1037 ints, and I can do that in basically one line of code. And then it also gives me a way to programmatically access each one of those variables. And so like in this way, you would have to explicitly write num item 86 equals whatever, 10 or something. So here, if you have to explicitly give the number, that's not that cool. But if there's a way we could have some variable like int I equals 86, and then basically say something like num item like subscript I or something, then this would be saying take the 86 num item and then set that to 10. So that's basically what arrays lets you do. And here's the syntax for making an array. You give the data type of the array that you want. So this is like an int or double or a string. It could be a class as well. So like our student class, you can make an array of students. So you put whatever your data type is, and then you stick square brackets after it, and then you don't put anything inside, so it looks a little weird, but that's the format that's been chosen. So you have a left bracket and a right bracket with nothing inside of it. And so this is basically saying, give me an array of this data type. And then you pick a name for your variable, just like you would normally. And if you like, you can just stop like there with a semicolon. Or if you want to actually create the array at the same time, you can set it equal to a new. And then you give your data type again. And then this time, inside the square brackets, you give it the size that you want. So if I wanted 10 things, then I'd stick the number 10 in here. And if I only wanted 2 things, then I'd put the number 2 in here. So real simple example, if I want an array of 6 integers, then I could write int square brackets, the variable name, in this case I'll just call it A for array, but you can call it something more meaningful, and equals new int, say 6. And so what this will do is inside memory, we'll have some memory address. I'll just make up a number. And then at that address, you could store element 0. And the way you access this is going to give me 6 integers, but they're indexed starting at 0. So it's kind of like when we were doing the random numbers. When you put that number inside the parentheses, you got a number from 0 to less than that number. This is kind of similar. You stick some number here. This gives you 6, in this case, integers, but then they're numbered from 0 up to 5. So the computer would pick some memory address that you wouldn't see this address normally, but it picks some address for the variable, and then the way you reference the first integer is bracket 0, and then it'll allocate enough memory to store an integer. It turns out that integers take up 4 bytes, and so the next memory slot would be 1004, and then you would reference this by A at index 1, and the next would be 1008. This would be at index 2, etc. 3, 4, and the last one is 5. And then there would be some value in the contents. So this is the address. So here's the memory address. What's actually stored there? Well, in Java, when you make an array of integers, for any numeric data type, Java initializes them to 0. So when you first start out, these will have all zeros here. That's not the case for some other languages. So if you do other computer programming and you start using C++ or something, you don't get all zeros here. So just a little warning for you. So what can you do with this? Well, basically we can treat these things just like they were any other variable. So just like you would do with any other integer, you can do the same thing with this. So I could write something like A at index 3. So I say A and then the square brackets with 3. And I could set it equal to something like 54. And so this would go to index 3 and then change this from 0 to 54. And I can also read from one of these just like it's any other variable. So I could say something like A at index 0 equals A at index 3. So this would retrieve what's at index 3, which is 54, copy that into index 0. So now I get a 54 over here. I can, since these indices are just integers, I can do math operations as long as I end up with an integer. So I could write something like A at index 5 equals A at index 1 plus 2. So here we'll add 1 plus 2 together to get 3. Go to A at index 3, that's got 54. That gets copied into A at index 5. And then I can use variables in the index. And so I could have like an integer I equals, let's say 5. And then I could do A at index I plus plus. And so I get set to 5. This would go to index 5. And then whatever is in here gets 1 added to it. And so this would become 55. So the bottom line is I can treat these like regular integers, but now I get the bonus that I can access them using a variable, or I could do math operations. So anything that results in an integer, I can directly jump around to different indices inside this array. So now if I'm doing my inventory thing, I could make an array that's of size, whatever it was, 1037, and that automatically creates 1037 integers. And I could loop through and set them to whatever I want, or go directly to index 86 and read that. So it's really handy when you have larger volumes of data. You do have to be really careful, though, not to try to access A at index 6. If I try to do that in this case, it would go off the end of the array, and we'd be trying to access something outside of the bounds of the array. And in Java, this will make the program crash. So if I tried to set A at index 6 equal to 10 or something, then Java will stop and give like an array out of bounds exception or some other error because we tried to access something beyond what was allocated. So this is a really common error because you look at this and say, oh, I made 6 things, and so there's a tendency to try to access that last one at index 6, but don't forget it starts at 0, and so you really get entries starting from 0 up to this number -1. So Java is actually kind of nice that it crashes for you. Other languages like C or C++ again, they'll just go ahead and access whatever is the next thing in memory and then just keep running. And that can result in just weird behavior for your program because if you don't know any better, you think it's working, but it's just accessing strange stuff out here. Okay, so here's another thing to note. If I have an array A, there's a tendency to want to try this. System.out.println A. And you might expect this to output everything inside the array, but that's not what happens. And so here, let's try it and see what does happen. So here's a blank program. I just say int, square brackets. I'll put you don't need a space there. I'll put one there just so you can see the square brackets a little better. A equals new int, how about, 6. And here I'll set a few of these. I'll set A of 0 equal to 10, A of 1 equals 20. So here I just set them to some randomly selected values. Oh, there's a mosquito. So you might do this system.out.println in A. So this does compile. But then when I run it, we get this weird thing. We get this @ sign and then 2B4936D. And so now that doesn't really look like 10, 20, 15, whatever. And so what's happening here is when you make an array, it's kind of like making an object. And so you have this array A, and there's some chunk of memory that's allocated when you use that word new. And then the array variable actually stores the address in memory of this chunk that was allocated. And then the chunk that's allocated is big enough to store whatever number of things in it, like in this case 6 things. So it's big enough to store like 6 ints, and so it would be storing those values there, 10, 20, 15. So like the 10, 20, 15, etc. All that would be stored in this chunk of memory. And so when I print out A right here, all it does is it prints out the address where it's being stored. So when you see this thing right here, this 2B, whatever, that's the address in memory where the array data is being stored. So you probably don't want that. If you actually want to output the contents of the array, then you have to make a loop that goes through and outputs each one of those 6 numbers. So we can do that pretty easily with a for loop. So it'd be something like this for int I equals 0, and I is usually the variable we use to iterate through a for loop. So we'll start at 0, go as long as I is less than 6, and then add 1, and then inside the loop we can just do a print statement, a, and then stick I inside the square brackets. So this will loop through. When I is 0, output a at index 0, and then I gets 1 added to it, and then I becomes 1, output a at index 1, and this will keep on going until I becomes 6, at which point the loop will stop, and then it's done. So this version outputs my 6 numbers, 10, 20, 15, etc. Yeah.
Can you, if you don't want to do a loop, is it possible to do system out line and then maybe like A1 plus A2?
Yeah, you could do that too. So if you just want to output specific ones, then you could specify them. So I could do system.out.println A0 and then like a space. So this would only output the first 2. Yeah. I don't like it. It makes me wait like an extra second before I can click the run button. So there's the 10 and the 20 there. So you can, that's perfectly legit as long as you don't want to print them all out.
Right. Another question I have is, say you don't, like, say you have 5, right? Or 6 total.
Okay.
Let's say you, say you want to specify in your loop when it stops, but you don't want to have to actually set 6. Is there a way to count how many there are? Or?
There is. So that's coming up next. So might as well do it right now. So if I go back to the loop, one downside of sticking the number 6 in here is, maybe at some point the array size changes, someplace else becomes 10 or whatever. So there's a couple ways you can do this. One way that some people like to do is to make a constant. So I could do this. I can make it maybe up. Well, I'll just stick it. I'll stick it inside main. Static final num. So here's the first way. I could make a variable that's static, meaning there's only one copy of it. Actually, and normally it'd be done up here. I'll do it the normal way. So normally you'd stick it up here and then make it public or private. I'll make it private. So here I'm making a variable that's private. By making it static, there's only one copy of it, like we were talking about yesterday. The final means that you can't change it. So once it's set, you can't change it to something else. And so this is how you define a constant. So if you wanted to store pi or e or something like that, or any value that's not going to change, you can do it like this. So this is saying I'm going to have 6 entries. And you could take this, instead of 6, you can put it down here. And you could also put it here. So here's the first approach. Whoops, I forgot the data type. So here I made an int. So here it runs just like before, but now I've got this num entries thing up here. And so now, later on I decide to make it 10 or something instead. I can just change that one place, compile it, and run it. And here we see it prints out now 10 things. And then the last 4 things are zeros, because Java initializes the integer array to all zeros. So once again, if you have a numeric data type, Java sets it to 0 for you. So here's one way. The other way is to not do this, and you just have whatever number you want it in here. Let's go back to 6. And then instead of using num entries like this, there's a way you can programmatically figure out the size of the array. And in Java, it is the array name dot length. And so now if I run this, then here I get 6 things. So for any array, if you want to know how many things are in that array in terms of what size it was when it was created, then you can access that using a.length. So like if I didn't put this a5 here, it would still give me 6 because it's based on this length is based on whatever number is used when I created the array. So that's probably the most common way that this is done in Java, is the arrays get set to whatever size you need, and then any place you need to go and loop through the array to do something with each element is you would use the array.length to figure out that array size. Okay, so what are some typical things we do? A typical thing would be like initialization. So maybe, so a typical thing would be you set each element to some initial value, like, whatever, 99. If you didn't want 0 as your initial value, then normally you'd have some kind of loop that goes through and sets each value to something. So here in this case, I set them all to 99. So here it outputs all 99s. I'm not limited to just outputting. I can put whatever I want in here, and so I could do things like set a at index I equal to a at index I plus 1. So in this case, I should get each one should be changed from 99 up to 100. So here I get all these 100s in here because I set them to 99 first, and then I go through and then add 1 to each one and then print it out. Let's see. Let's get rid of this. Another thing, sometimes you know exactly what you want to put into the array. So like in this case, if I know a at index 0 should be 10 and a at index 1 should be 20 and so forth, rather than type them all in one at a time, I can make the array and then set them at once. And so the alternate way to do this is as follows. I just use curly braces. And the curly brace format says make an array and then set the initial values to 10, 20, 30, 40, 50, and 60. And then Java will go through and count how many values are in here, and it'll see that there's 6 of them, and then it'll make the array big enough to hold all those values. So if you know right up hand when you're writing your program, I want an array of 3 numbers that are these, you can just stick them right in there all in one shot. And obviously this doesn't work too well if you got like a really big array, because then you have to type in lots of stuff. But for smaller things, then it's pretty convenient. So if I put my loop back in here where I print them out, now this should output 10, 20, 30, 40, 50, and 60. So there's my 6 numbers. What else? So let's do a little example. So let's say we would like to input 10 numbers and calculate the average. So you could do that without an array, but in this case, let's input the 10 numbers, stick them inside an array, and then loop through the array and calculate the average. If we wanted to calculate something else, like some other statistical stuff, like the standard deviation or something, then you'd need to remember the numbers. So if we want to make an array of 10 numbers, then I can say int a equals new int and give it 10 here. So don't forget to do this part, because if you don't do the new int stuff, it's not going to make the array and allocate memory for it. So next we'll say, put down there, input the numbers. So I can make a for loop for int I equals 0, I less than a dot length, I plus plus. So this for loop is like really common using to loop over an array. So we'll ask the person, enter a number. And in this case, I need a scanner, and I'll add one up here. So next I'll read in the number. So I have two ways that I can do this. I could say num equals keyboard.next int. And then I could set a at index I equal to num. So here we ask the person to enter a number. Whatever we type in gets stored into the variable num, and then that gets copied into the array at index I. Another way we could do this is we could just bypass this num, and we could just go directly into the array. And so I could go straight to a at index I equals keyboard.next int. So we type something in, that gets stored straight into the array at index I. So this should loop, in this case, 10 times, and then each number gets copied into the array. And then if I want to calculate like the average, for example, then I would have, after I put in all my numbers, I have another loop to calculate the average. We need the sum. So make a variable for sum that starts at 0. And then here's another loop that goes through the array. Instead of printing each number out, we'll say sum plus equals a at index I. So that's the same thing as saying sum gets itself plus the current value in index I. So after this loop is done, sum would be the total, so we can calculate the average. I'll just do them all as integers, but you might use doubles or something. So the average is the sum divided by the number of numbers. In this case, the number of numbers is a dot length. And then I could print it out. So declare the array up here, loop through all 10 of them where we input into the array, another loop that goes through each number in the array and accumulates a sum, and then calculations for the average and print it out. So here it's going to ask me for 10 numbers. I'll do, let's see, 9, 9, 9, 9, 9, 9, 11, 4, whoops. I put too many 9s in. Let's try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here I put in 5 9s and 5 11s, and here it tells me the average is 10. Let's see. A really common error is to be off by 1. I mentioned this before, where we try to access a at index 10 in this case. That could happen, like if right here, instead of a less than, I did less than or equal to, in which case it's going to try to input into A at index 10, which is one more than I've allocated space for. If you do that, then here's the error message that we get. So if I do one more, this is the 11th one. And then you get this kind of message, array index out of bounds. And so if you see that, then that's an indicator to you that somehow you exceeded the size of the array. Okay. So just a few other little things I'll briefly mention here. The first one is that arrays are objects. This is why we can say a.length, and it tells us the size of the array. And so an array is not a primitive thing like an int or a double. We've actually got methods and other things you can do with arrays. And the other thing we saw is when we printed out A is an address to the object in memory. So if I had something like this, int brackets A equals 1 comma 2, oops. And then another thing here, like int bracket B equals 1 comma 2, or let's do it this way. So here I've got two arrays, A and B, and they contain the same thing. A contains 1, 2, B also contains 1, 2. And so you might be tempted to do something like this. If A equals B, then do stuff, else, do something else. So you might want to check to see if two arrays are the same. And if you do this, then it'll compile, but it probably won't do what you want. Because what Java will do is, we saw when you printed out A, you got the address of it. And so the same thing is happening here. If I compare A and B, it compares the address of this array with the address of that array. And most likely they're different things. So A is probably pointing to one place in memory. B is pointing to a different place in memory. Their contents happen to have the same numbers in it, but they're in different places in memory. And so this is most likely going to be false. And I say most likely because sometimes Java will do things and actually make them be the same place in memory, but usually it's going to be different. So this isn't going to actually compare the contents of the arrays. It only compares the addresses to see if they're the same. So we have kind of the same thing like you had when you tried to compare strings. If you had two strings, you couldn't just use equals equals with strings. You had to use like string 1 dot equals parentheses the other string. And there's a similar thing that you could use with arrays. But essentially, you would have the job, if you wanted to see if two arrays are the same, then you would have to write some code that would say, are the arrays the same size? And if they're the same size, is the first element equal to this first element? And is the second element equal to that second element? And so if all those match up, then you could conclude that they're the same. So I just thought I'd point that out, that you can't use equals equals on arrays, and it doesn't compare the contents. The other thing you can't do is you can't assign one to the other, so you can't write B equals A. And so in this case, if you try to do this, well, you can you can do this, but you get some interesting behavior. So let me write out this example. Or maybe I'll just type it up here because then I can run it if I want to. So let's say we have some array A. That's okay, let's see here. Oops. Okay, so here's my little sample code. So here we make two arrays that can store 3 things each, and then I set the A array to have all ones, and then the B array has all zeros. And then we just print out the first element of each. And then if we do B equals A, you might think that this would copy array A into array B, and then, but it's not quite what happens, even though it sort of looks like that. So maybe the best thing to do is normally just start at the beginning and write what will really happen. So at the very beginning, A is set to an array of 3 ints, and so A references some place in memory that can store 3 integers. We set them to all ones. Same thing for B. B references a place in memory that can store 3 integers. They're all zeros. And then right here, we print out A at 0, so that would print out 1, and then B at 0, that would print out 0. If I did B equals A, the misconception is that all of these zeros would get copied into the space for the A's, and so you might think that I would copy 3 zeros in here, but that's not what happens. Instead, when I have the assignment, what happens is B gets, I did it the other way around. So you might think that A would be into the B, where all the ones would overwrite the zeros. But instead what happens is B gets set to the same place in memory that A is. So A is referencing this place in memory with ones, and so B is now going to reference the same place in memory. And so you can think of this as like B is pointing to there. And so now when I print out A of 0, it goes to A, and the first thing is a 1. And then now when I print out B of 0, B, we go to the first thing here, and it prints out a 1. And so if you didn't know any better, you might have thought that all the 1s got copied into the B array, but they didn't. The B array is still all zeros, although you can't get to it anymore because you've lost the address to it. It's been changed over to the place where A was set. And you can tell the difference because right now, if we do A of 0 equals 9, then this first guy goes from 1 to 9. And then now if you print these out again, A at 0 is 9, but then B of 0 somehow magically gets changed to 9. So if you had the idea that it was copying them, then this would just be confusing to you because like, oh, wow, why did this only change to 9? And the reason is it doesn't copy them. It only sets the memory address from one array to the other. So now I've just got 2 arrays that are referencing the same place in memory. So if I change something from one array, you'd see that change when you access it from the other one. Okay, so in Java, there's just a little extra for you. This thing over here is called garbage. And that's because you have no way of accessing it anymore. The only way to get to it used to be through B, but now B doesn't reference it anymore. And so what Java will do is periodically it'll go through memory and it'll reclaim any garbage so it could reuse that memory if it needs to. But if it doesn't need to, then it'll just sit around until your program quits. Okay, so if I actually wanted to copy one array to the other, then you have a couple ways to do it. One is there's this thing called clone, where we could write, so instead of b equals a, I could say b equals a dot clone, and then I'll make a copy of a, and then b gets set to it. The other way you could do it would be to make a loop. And then inside there you'd set b at I equal to a at I. So this will loop through every element in A and then copy the corresponding integer from one to the other. So if you're doing it like this, you have to make sure that B is big enough to store the data. So like if A was holding 1,000 things, but B was only allocated to store 10 things, and this would try to copy 1,000 things into space for 10 things, and that wouldn't work. So just make sure the destination array is big enough to hold the information. So what we've covered here are called one-dimensional arrays. Oh, you have a question?
Yeah, sorry. So can you go the other way? Can you copy 10 into one that's larger?
You can, but then whatever's there before would just be unchanged.
Okay.
Yeah. If I did the clone, then that would make a copy, and then so if I had like A references a thing with 2 things, and then B was holding 4 things. If we did like B equals A dot clone, then this makes a copy of a new thing that has 1, 1, and then B gets reference to that, and then this thing becomes garbage. So if you use the clone, then you lose your extra spot. But if I made a loop that only went 2 times, then it would like copy the first 2 into here, and the rest would stay unchanged. So this is called a one-dimensional array because you just have one index. We can also make 2, 3, 4, 5, up to n dimensions, and normally you wouldn't go beyond 2 or 3. And so if we have a 2D array, you can think of this like a table. So the way we would do it would be give your data type, and then instead of 1 pair of brackets, you would have 2 pairs of brackets, and then you pick your variable name. And then you just fill in the size of each dimension. And then you can access this by saying 2dim array index 1 index 2 equals whatever. And essentially what this gives you is an array of arrays. So you can think of it like a table where you've got, in this case, like 3 and so in this dimension where I had 3, I get 0, 1, 2 rows. And then here I had 4, I have 0 through 3 as the columns. And then if I say 2dim array 0, 1 equals, let's put a number here, 10, then it'll be going 0 to 1 and sticking like a 10 there. And if I change this instead to 2 equals 110, then it'd be like sticking a 110 right there. So if I wanted to have a table of information, then I could make a 2-dimensional array with whatever sizes I want and then stick things inside and read them out. So when we were doing the stuff with processing images, it's kind of the same idea. We had like a loop that went across all the rows and another loop that went across all the columns. And you could do a similar thing here, except read from the array instead of reading in a pixel color. Let's see. So one thing I did want to mention is Java really doesn't make a table. So you can think of this mentally like a table. But what Java really does is it makes an array of arrays. And so internally, Java does this. You would have 2dim array, and then that would point to someplace in memory that could store 3 things. And then out of those 3 things, this one points to another place in the memory that can store 4 things. So when I access 2dim array 2, 2, what Java really does is it goes to index 2 of this first array, like right here, and then it goes to index 2 of the second array, which would be right here, and then that thing gets set to 110. So that's what's happening under the hood. If you know this, you can take advantage of it, and you could, like, if you wanted to, you could have this point to a new array that only has 3 things in it or 10 things in it, so you can make these arrays of different sizes. So you can do some kind of funky things, but normally you just keep it the same dimensions and treat it like it's a table. So since we can do 2D arrays, just like you might guess, you could also do 3D arrays or 4D arrays, and so you would just add more brackets on here for every dimension that you want. And there's a limit, but I think it's like 15 or something like that. So I don't think you'd ever go more than 4 dimensions. In fact, 3 is probably the limit, really. Once you get beyond that, it's kind of hard to mentally keep track of what all the indices are. Okay, so let me do one last thing. And that's how you would send an array into a method. So let's say I have some method here, public void whatever foo. And let's say I would like to send an array in. The way you do that is you would specify the data type of the array. Let's say it's an int. And then you use the square brackets. And then you give it a name. Don't use the new or anything up here. And so it's only specifying what the data type is in the brackets. So there's no, you only use the new once when you try to allocate the array. And here I'll just give an example. Let's say, let's call it something else. I'll give it an actual name. I'll just call it A. All right, so let's say I had this. I am in here in main, and inside main I create an array that can hold two things. It's supposed to be. So if I draw a little picture of it, A in main references someplace in memory, and it's got 1 and 2 in it. And then if I want to send that array into a method, I give the method name, and then in parentheses I give it the array variable. And so don't put any square brackets here, so there's no square brackets go here, just the variable name. And what this will do is when I have the variable name without anything attached to it, that's the address of the place in memory where the array is stored. And so it's going to go and send the address in over here. And so now whatever I call this, I happen to call it the same thing A, but so this is going to reference the same place in memory where I created the array down here in main. So now if I go and change something, like I said A at index 0 to 100, then it changes it inside the array. And then when this thing exits, this array variable A goes away. But back here inside the main, if I tried to access A of 0, we would see that it got changed to 100. And so with arrays, it's like passing them in like objects. If you change the contents of the array, then that changes it everywhere it is in the program. And so like here in the calling place, it gets changed if the contents get changed inside the method. So here, let me just show that real quick. So, and actually maybe I can do that in this example I was going to do later on here. So I was going to do this example where I can still do it, where we input 10 numbers, and then let's go and find the minimum and the maximum. So maybe we want to make a method to input the 10 numbers. So let's go and get rid of all this. Let's get rid of that too. So right now I just have a main that makes 10 integers, and so let's make a method here to input them. So I'll make it public. It could be private. I am going to make it static, and so the reason for making it static is so I don't have to make an instance of the Java program object. I can just call it directly by name from main. So I'm going to make a public static void input numbers, and then as input I have an array, and I'll just call it nums. And then inside here, I'll make a for loop for int I equals 0, I is less than nums.length, I plus plus. And then I need a scanner so I can read from the keyboard. And then basically the same thing we had before where I read from the keyboard. I'll say nums at index I equals kbd.next int. So this thing right here will input, will loop through the length of this nums array, and then for the length of that, it's going to input an integer and then store it inside that array. And to call that method with the array, down here, I just say input numbers and then give it A in parentheses. And then just to test to see if it's working, I'll make another for loop here. And just print out the numbers. So up here, loop through, input the numbers. Down here, make the array. Here's how we send the array into this method. So here when you send an A, it takes the address of A in memory. Nums get set to that same address in memory. So when we changed the nums array, it's really changing the A array at the same time. And then here we just print them out. So here it's going to ask me for, in this case, 10 numbers. So I just give it all 9s, and then now it comes back and it prints them out, and it's printing out all 9s. So once again, if I send an array in as a parameter, and I change that array inside the method, those changes get reflected back here inside the original array because they're both referencing the same place in memory. Let's see, so that's a little bit of the logistics of just sending an array in as a parameter. Let's do another method that calculates what I have in my, finds the minimum. So I'll make a public static. In this case, let's return back the minimum. So I'll make it an int as the return type, and I'll call it find minimum. And takes as input the array of nums. So let's try to write this in as a generic way as possible that works with any array of ints. So the first thing we might test to see would be, well, if the array has 0 things in it, then I don't know what to return. Maybe we'll return back 0. And you could kind of pick what to return back if the array has nothing in it. So I can do that with an if statement. So if nums.length equals 0, then there's nothing to return, so I'll make it return, how about -1? So that could be like our special number in case the array is empty. So that's kind of up to you. You could design this so you return 0 instead or something else. If we get past this, then it means that there's at least one thing inside the array. And so the strategy can be, let's keep track of the smallest thing we've seen so far. So let's make a variable that's called minimum, or let's call it min. And I'll start by sending it to nums at index 0. So I'll assume that the first element is the smallest. And then I can make a loop that starts at index 1, the next element, and then goes through all the other values in the array. So as long as I is less than nums.length, I++, we can check to see if the minimum we found so far is bigger than, so if min is bigger than nums at index I, then it means we've found another value that's smaller than the current minimum. So then we should set min equal to nums at I. So here basically, if I diagram our strategy, if I have an array and that's got 2, 5, 1, 6, then I set min equal to 2, and then I sets equal to 1. So this is at index 0, 1, 2, and 3. So then we compare the 2 to 5, and well, 2 is less than 5, so nothing happens, and then I gets 1 added to it. And then we compare the 2 to the 1, well, 1's less than 2, so min becomes 1, and then I gets 1 added to it. Then we compare the 1 to the 6, and well, the 1's smaller, so nothing happens. And then we reach the end of the array, and when that happens, min should have the smallest value inside the array. So at that point, that'll be right here at the end of our loop. Oops. 4. So right here, I would say return min. And so this should return back the smallest number it's found inside the nums array. So to use it, I'll get rid of this print here. I'll just do system.out.println. What did I call it? Find minimum. and then we're sending the array A in as the parameter. So we input the numbers here, print out the minimum there. So compile and run it. I'll give it some numbers, 10, 10, 30, 40. Here's my minimum of 3. And it's gone through and it spits out the number 3, and so it has gone through and found the smallest number. Okay, so we could pretty similarly find the maximum. We would just, flip this to greater than instead of less than. And I guess one last thing I'll just briefly mention is you could also return an array if you want. So here's just an example: public static int get array. So if you wanted to, sometimes you want to return an array as your data type, and to do that, you make the return type be whatever you want with the square brackets to say it's an array. And then that means that inside the method somehow you have to make the array. So here I've made an array of 4 ints. I set one of them to 100 and then return that array. And so just as an example, here's how you might use it. I'll put some more numbers in there. New array. So here I made an array A. I don't have to set it equal to a new thing because that's going to be done in here. And so at this point I have like an array, but it's not set to anything. And then if I call this method that returns an array, then I set my array variable equal to the return value. So A should be set to the array that has 104, 33, and 99. And then here we print out the minimum, so it should print out 4, since that's the smallest number inside there. So there's the 4. So I don't think you'll have to do this in any of your programs for the class, but if you wanted to, then it's possible to return arrays. So those are the two things with methods and arrays: sending them in as a parameter and then returning them back. So hopefully you can send them and retrieve them from methods if you want to. Okay, so I'm going to stop talking here and then let you work on the array part of the drill. And then then we'll do more arrays tomorrow, and then probably still more arrays on Thursday.